Okay, good morning to everybody. Today we'll discuss how to solve the differential equation by undetermined coefficient. Actually, in previous class we have discussed detailed how to solve the differential equations by variation of parameters method. So today we'll try to understand the undetermined coefficients method. And undetermined coefficients, there are two types, two procedure. One is superposition approach, and another we'll see later. Uh, as an introduction, how to solve a non-homogeneous linear differential equations. Actually, this is the nth order non-homogeneous linear differential equation, equation one, because the right hand side, this is the function of x and it's not equal to 0. We must know if right hand side is 0, then these differential equations will become homogeneous. So there are right hand side z of x function is non-zero. This is why it is non-homogeneous differential equation. So we must do two things here. Find the complement. We should find the complementary functions yc, and hence the find any particular solution yp. Then these sums will be the general solution of the given nth order non-homogeneous linear differential equations. Actually, we have solved these types of differential equations in the method of constant coefficient method. Linear differential equation with constant coefficient method we have solved. Okay, the total solution of these types of differential equations and order non-homogeneous differential equations will be y equals to complementary function plus particular integral. Actually, this is the complementary function and this is the yp is the particular integral. This sum will indicate the whole solution. Okay, particular solution, of course, this. Okay, what is the method of undetermined coefficients actually? The first two way we shall consider the obtaining a particular solution. How to find out the particular solution? Yp for a non-homogeneous linear differential equations, then the method is called undetermined coefficient. Okay, so the underlying ideas behind the method, this method you must to penetrate to this method. First of all, the coefficients I equals to 0 to 1 are constants. Actually, this ai for I equals to 0 to n, all ai will be constant, and zx is a constant k, a polynomial function. The exponential will be e to the power alpha x. A sine or cosine function such that suppose there is another function sine beta x or cos beta x, or finite sum of product of these types of functions. So if the linear differential equations, non-homogeneous linear differential equations, zx can be formed like this, then we can solve with the undetermined coefficient method. So suppose example 1, the general solution using undetermined coefficient. How to find out the general solution? Actually, this is the second order because highest derivative is 2, second derivative. This is why this is the second order differential equations, and right hand side is non-zero, and this is the function of x. This is a polynomial actually. So first step, in every example, we have to start with step 1. We first solve the associated homogeneous differential equation. That means taking right hand side 0, we left hand side equals to 0. We get, okay. That means it becomes homogeneous form. So you can solve this homogeneous form by the what method actually? Determine constant coefficient method. We can solve this. That means we can form a particular complementary function, then find the complementary function. From the quadratic formula, we find the roots of the auxiliary. That means the complementary function will be what? If e to the power mx be the trial solution of this, then complementary function will be m square plus 4m minus 2 equals to 0. After solving this for m, we can find out two roots. Actually, m1 equals to this and m2 equals to this roots. So two roots are found. Hence, the complementary function can be written as yc equals to first constant C1 e to the power m1x plus C2 e to the power m2x. That means this is the rules for writing complementary function. We have seen it in our previous lecture of what the constant coefficient method. Now in step 2, now because the function gx is a quadratic polynomial, actually this is the quadratic polynomial, right? This is the second degree polynomial because the highest power of x is 2. So this is the second order polynomial. So now because the function gx, this is the gx, right hand side, whole function gx is a quadratic polynomial, let us assume a particular solution that is also in the form of a quadratic polynomial. That means we have taken yp, that means yp means particular integral, okay, will be what? A x square plus bx plus c types, okay. This is the, just comparing this, we can write this standard form, x square plus bx plus c types polynomial. So we seek the undetermined specific coefficients ABC. We have to determine this coefficient, right? So this is why this method is actually called undetermined coefficient. That means we'll try to find out this constant A, B, and C constant. This is why it is called method undetermined coefficients method. Now we try to seek the specific values of ABC for which YP is the solution of 2. That means YP means what? Particular integral. Now substituting YP and the derivatives. That means first derivative of this, taking ddx on both sides, differentiating YP with respect to x. First derivative will be what? Twice x plus b. X formula will be 1. This is why only b, and c is the constant 0. Okay. Now second derivatives, if we take again derivatives on both sides, double derivative will be y double dash p equals to what was? What is? Twice a, because the differentiation of x is 1, and b differentiation of single b constant will be what? 0. This is why double differentiation will be twice a. Now putting the given differential equation is in equation 2. Equation 2, this. Now substituting these values in equation 2, we get this one. Okay. Just y double replacing y with yp, y dash p. Okay. Y double dash p plus 4y dash p minus 2yp equals to what will be? Twice a plus 8x. Just putting these values. Twice a, this twice a for this. And 4 into y dash p, what? 4 into this. Okay. We get this one. Minus 2 into yp. Minus 2 into y means what? This. 2 into whole this. We get this one. This equals to right hand side. Okay. Now, because the last equation is supposed to be an identity. Okay. Identity equal. This both term, left hand side and right hand side, are equal. This is why it's look like an identity for every values of constant on both sides. So the coefficients of like power of x is must be equal to. That means just arranging this left hand side with x square coefficient, that means this, and x coefficient and the constant term. Okay. And in right hand side, just put it. Now equating coefficient of x square on both sides. That means x square coefficient 2 here and x square coefficient y minus 2. This is why this is equal. And x coefficient what? 8a minus twice b, and x coefficient what? Minus 3. These are this equal. So constant term and constant term will be equal. So equating on both sides. Okay, we get this. Now solving for a, b, c, we get a equals to what? Minus 1. And b, putting a equals to minus 1 here, we get b. Okay. Now putting a and b in this equation, we get the value of c. So at last, solving the system of this system of equation leads to a equals to minus 1, b equals to minus 5 by 2, and c equals to minus 1, minus 9. So yp means particular integral. We have considered this, just putting a, b, c, and we get the particular integral is this. So the general solution can conclude that y equals to complementary function plus particular integral. So complementary function, and this is the particular integral. So this is the actually result of this differential equations by undetermined coefficient method. Okay, find a particular solution of y double dash minus y plus y equals to 2 sine thrice x. Okay, now a natural first guess for a particular solution would be a sine thrice x. Okay, this taking this as a constant, a sine thrice x. But after differentiation, successive differentiation, sine 3x produces what? Sine 3x and cos 3x. Okay, sine become cos after differentiation. This is why we are promoted to instead as assume a particular solution that includes both these terms. We have to take the particular solution taking both these terms. Okay, a sine 3x plus a cos 3x plus b sin 3x. Okay, just we have to take this as a particular integral because the differentiation of this will be what? Cos. Now differentiating yp. Take after differentiation, first differentiation with respect to x on both sides, we get the term and again differentiation, double differentiation of this. Okay, then putting here just before, look like before example, double differentiation below, first differentiation below, then right hand side. Okay, y below means this, then adding and subtracting we get this. Now cos thrice x coefficient this. Okay, but here cos thrice x coefficient what? 0, because there is in right hand side there is no cos thrice x. Now sin thrice x coefficient what? 2. Here sin thrice x coefficient thrice a minus 8b. This is why equating on both sides the coefficients from the resulting system we get minus 8a minus thrice b equals to 0 and thrice a minus 8b equals to 2. Now solving for ab, we get a equals to 6 by 73 and b equals to what? Minus 16 by 73. Just solving. The particular solution will be becomes putting a and b values yp. Yp will be this. Okay. So this is the particular solution. Now general solution what will be? Y equals to yc plus yp. Yc how we will find? Taking right hand side equals to 0, then y equal to mx, y equal to e to the power mx with the trial solution, then m square minus m plus 1 equals to 0. Solving for m, we get two roots, maybe complex roots. Okay, so this will be the particular integral. Now another example. So this is the actually non-homogeneous second order differential equations. So in first step, the solution of the associate homogeneous equation, we first of all we have to take right hand side is 0, then it will become homogeneous. Now we can solve this with the complementary function method. Okay, now we can find the complementary function yc equals to what? C1 e to the power m1x plus C2 e to the power m2x. Now e to the power, if e to the power mx be the trial solution of this, then it will become m square minus complementary function what will be? M square minus twice m minus 3 equal to 0. Then solving for m, we get two roots. One equals m equals to minus 1 and another one will be 3. So complementary function will be this. This is the constant coefficient method in our previous lecture. Now observe the right hand side. There is a actually linear function. 4x minus 5 is the linear function. Okay, this is the linear particular solution will be polynomial. Okay, now 6x into e to the power twice x. This is the product of two functions, right? X into e to the power twice x. So this produces actually after differentiation we get twice x into e to the power twice x. Okay, and again differentiation in UV process we get another part will be e to the power twice x. So in particular integrals, we have to take gx will be first function and second function. That means polynomial function and exponential function. This is the polynomial function and this is the exponential function. So total particular integral will be first part p1, second p2. First p1 is the what? Linear function x plus b, and second one will be what? Cx. This into c, this into what? C into this and E into this. Okay, just taking this A, B, C, E is the constant is the coefficient of all terms. Now D is absent because D we consider the differential operator. This is why D is not taken. We have not taken. So now putting this in equation 3, just differentiating first times y dash p, then again differentiation y double dash p, we get the values. and substituting these all values in the given equation. Okay, just look like previous example, example 1. Now just putting these all values here, we can equate the constant, and x coefficient 4, here x coefficient what, minus thrice a, here constant term what, minus 5, here constant term is this, minus twice a minus thrice b. Okay, so here x into e to the power twice x coefficient what, actually actually e to the power twice x here absent, so e to the power twice x coefficient will be 0. Understand? And x into e to the power twice x coefficient what, minus thrice c. Minus thrice c equals to what will be 6. Now so we get a equals to here minus 4 by 3. Okay, then putting a values of a, we get b equals to 23 by 9. Okay, then c equals to what, minus 2, and after putting values of c here, we get the values of e equals to what, minus 4 by 3 consequently. So now substituting these all values of a, b, c, e in equation what, this particular integral. Okay, yp, we get this is the particular integral. Now the general solution will be what, y equals to complementary function plus particular integral. Understand everybody? Okay, another example, find a particular solution. This is the non-homogeneous differential equations of second order. Now in differentiation of e to the power x produces no new function. Okay, after differentiation of right hand side, we get these types of differentiation function. This is why no repetition of another function. So therefore, the proceeding as we earlier examples, we can reasonably assume a particular solution. Yp equals to what will be a to the a into e to the power. So we have to find out the only this coefficient. Okay. Now the particular solution what will be, just if we take e to the power mx, y equals to e to the power mx be the trial solution of this equals to 0, complementary function m square minus 5m plus 4 equals to 0. Then solving we get two roots, m equals to 1 and 4. Okay, 1 and 4. So complementary function what will be, c1 into e to the power 1 into x plus c2 into e to the power 4x. Now observe that our assumption, this is the particular integral. Okay, particular integral. Now yp equals to x a into x into ex. Now taking differentiation, y dash p will be this. Okay, UV process, and then and again differentiating this, we get double differentiation will be this. Now substituting these all values in our given differential equation second order. So after equating on both sides, minus thrice a equals to what, 8. Okay, minus thrice a equals to 8. So I equals to only minus 8 by 3. So yp equals to, this is the actually what, particular solution. So the this is the actually result. You can solve these types of also. Now an initial value problem, how to solve these types of initial value problem. Initially, if x equals to pi, then y and y dash are given. Actually, this is the second order differential equation and non-homogeneous. So this is why two initial value is given to find out the constant term. There will be two constant. This is why two initial value will be given. So solution will be the solution of the associated homogeneous. Now taking homogeneous, right? Taking right hand side will be 0. We get homogeneous form. The left hand side equal to what? 0. We get the homogeneous equation. So complementary function what will be, m square plus 1 equals to 0. That means m equals to what, plus minus m equals to what, m square plus 1 equals to what, m equals to plus minus I. That means two complex roots we get. So complementary function for the complex roots can be written c1 cos x plus c2 sin x. For complex roots we have to write the complementary function like this. You can follow the previous lectures constant coefficient method. Now the right hand side, observe the right hand side, there are two functions. One is linear function, another is trigonometric function, right? So the sum of a linear polynomial and sine function. Understand? Now our normal assumption for YP will be from entries 2 and 5. We can use the table actually 4.41. So the first particular first part for the first function polynomial will be x plus b. Okay, just look like previous example. Now x plus b, first part of the particular integral, and second part for the trigonometric part, we get differentiation of sin x part cos. This is why we have to take the linear combination of sin and cos for the second part of the particular integral, right? So total particular integral what will be this first particular integral plus second particular integral combinedly, and this is the equation number 5. Now differentiation of this and taking double differentiation, then substituting in the given differential equation, we get the form this. Now equating the coefficient, because the undetermined coefficient method, this is why you have to match the coefficient on both sides. Coefficient of x equals to here 4 and coefficient of x here a, so a equals to 4 and b is the actually constant term, here constant term absent, this is why b equals to 0, and sine coefficient what, minus 2ic here only 10, this is why minus 2ic equals to 10, and here okay, the initial value problem, an initial value problem y double dash plus y. This is actually second order homogeneous differential equation, non-homogeneous differential equation. So there are two given, actually two given um, initial conditions, because this is the second order differential equations. Now the particular integral can be written as like this. For this is the linear function and this is the trigonometric function. So x plus b plus c cos x e sin x, because after differentiation of this term we can get cos. This is why the linear combination of sin and cos can be written as the second part of the particular integral, and this is the linear function, first part of the particular integral. So total particular integral is this. Now taking differentiation, first differentiation and second differentiation, and then putting all these values in this equation, we get the form this. So equating the equal terms on both sides, so we get a equals to 4, b equals to 0, and minus 2c equals to 10, because sine coefficient 10 and here sine coefficient minus 2c. So we get the actually we get the form here, a equals to 4, b equals to 0, c equals to minus 5, and e equals to 0. Therefore from equation 6, after putting all these values, we get the complementary function, particular integral 4x minus 5x cos x. So total solution, general solution of the given second order inhomogeneous differential equation, complementary function plus particular integral, this. Now we will apply the initial conditions to the general solution of the equation. We are given the initial condition y phi equals to c1 cos pi plus c2 cos pi. Just putting x equals to pi on both sides of this, okay, then we get y pi. Y pi equals to c1 cos pi, c2 sin pi plus 4 pi minus 5 pi cos pi. Okay, remember sin pi must be 0 and cos pi equals to minus 1. So we get the form c1 equals to 9 pi here. Okay, and 4 pi c1 equals to actually 9 pi. Now since cos pi equals to minus 1, sin pi equals to 0, next from the derivatives, taking differentiating on both sides of this, we get y dash p equals to minus 9 pi sin pi c2 differentiation cos x differentiation 1. This is why 4 only. So this is the UV process. So we get this one. Okay. Now taking the another second initial conditions, y dash pi equals to, just putting x equals to pi here. Okay. We get y dash pi equals to minus 9 pi sin pi c2 cos pi 4 5 pi sin pi minus 5 cos pi. So putting this cos pi equals to minus 1 and sin pi equals to 0, we get c2 equals to 7. So putting c1 and c2 in our general solution of the differential equation, we get the complete solution of the given non-homogeneous second order differential equation is this. Similar process, we can solve this. This is left for you at you'll try to at home. Okay, this is the third order. Similar process, we can solve the third order differential equation with the constant, with the undetermined coefficient method. And this is also fourth order. Okay, fourth order complementary function will be what? This is fourth order, and this is the third order. So highest derivative is 4. This is why fourth order non-homogeneous differential equations. Okay, after differentiation of this, we get this 3 form. Okay, this is why we have taken, and this is the constant function first part, and this is the exponent product of two functions. So we have to take the complementary function. We get m4 plus m cube equals to 0. So we get 4 roots here. This is why we have taken, and repeated roots, 3 repeated roots. This is why we get the complementary function is this, and particular integrals will be consist of 4 constant, because we after a UV process we get these 3 term, and this for f is a is for only constant term. So we get the whole particular integral like this. Now particular integral is this, then differentiating 4 times. Differentiate first y dash p, y double dash p, y triple dash p, y fourth differentiation, then putting this we get the particular integrals, then equating the determining the undetermined coefficient, that means coefficient of a b c e, we get we can put this in this particular integral, then we get the general solution of that. So after 27 to 31, this will be the homework for you, this initial value problem, and of course non-homogeneous. This is the only second order. This will be homework for you.